Good afternoon, everybody. Thanks very much for joining us here today. My name is James Parks. I'm a marketing offer manager at Schneider Electric, and myself and Deepak are going to speak to you today about the smart power systems and connectivity. So I'll hand you over to Deepak.
Thank you, James. Good afternoon to you all. So my name is Deepak Sharad. I will be co-presenting with James. I'm the marketing and offer development manager for final distribution systems for Schneider Electric in the UK. So as a part of the session, we'll give you a background on who we are, some of the topics around sustainability in the future, how this links into smart buildings and smart spaces, how the connected electrical network has changed and is evolving, and then the sort of changing demands on them, smart power systems and connectivity, and then we'll have closing thoughts at the end, and we will leave some time at the end for a Q&A session. If you do have any questions, if you want to put them into the chat dialog box, that would be fantastic. So let's start with a short video on who Schneider Electric are.
The world is full of people telling you who to believe they are. Well, we thought we'd tell you who we're not. Let's start here. We're not in shipping. We don't make lifts. Seriously, no lifts. We do this. We're good at this. And we make all of these. And even though you'll find us here and here, we don't make energy. We make you save it. And you'll be saving the environment too. Are we an internet company? Well, we connect and power just about everything around you, helping machines talk to each other and to you, making your world more personal. We're seeking out the big questions and answering them honestly. Like, how can we make the most of our energy and resources? Or can we make access to energy and digital basic human rights? We're real people, employees, developers, partners, investors, and inventors, all passionate about doing what's right. We're open, humans of all sorts from all over, learning from each other and about each other. We're not here to save the world. It'll go on with or without us. We're here to be your digital partner for sustainability and efficiency, to ensure life is on everywhere, for everyone, at every moment.
So that really sets the scene on who Schneider Electric are, and you'll see as we go through the presentation on how some of these points really sort of relate to electrical distribution, energy management, sustainability topics. So let's have a look at where we are today. So if we look at the period that we're living in, I think we all can see that there's been only one winner out of this COVID-19 period, and this is the acceleration of digital. It's accelerated digital adoption better than any CEO, CFO, or CDO would ever have been able to achieve. And at Schneider Electric, we've been leveraging the digital for efficiency and sustainability for a long time now. But what we've seen is an increased reinforcement of the values of resilience and the capacity to do everything from remote during this COVID-19 period. And we'll start to go into a little bit more about what this really means. So the future, what we've seen is there's been a lot of investments into healthcare environments, for example. But whilst we've been in this environment through the COVID period, and we've been pushing through this pandemic, the government have actually published a paper outlining the plan for a green industrial revolution. So we can start to really see some of the key areas that link cleaner and safer power generation and distribution. But in the main, all of it links back to having greener buildings. So we can see some of the things around point 7 with greener buildings, investing in carbon capture, usage and storage, protecting our natural environment. So some of these key topics are really coming to the forefront now. So the industry vision From an industry standpoint, it's very much the same as what the government is trying to do. As a part of the industry, BEMA are really trying to push forwards towards a net zero emissions by 2050 target. And we've committed as an industry to reducing our own emissions as well as meeting the needs of the supply chain for this transition to net zero by 2050. And some of the BEMA members have already gone a step further beyond this and made individual commitments to meet net zero by 2030 for their global operations. But for us, for Schneider Electric, our vision is to further accelerate this beyond the agreed targets that are within our industry. And let's have a look at what this really means for us. So that gives you an insight into our sustainability strategy and how we are really trying to accelerate towards a net zero ambition. So we're really proud to be awarded the most sustainable company in 2021. Not only do we empower to make the most of energy and the resources, but our sustainability goals and development goals go far beyond this, whether it's linked to health and well-being, education, gender equality, clean water and sanitization, life below water and on land, and then affordable and clean energy, industry innovation and infrastructure, which starts to link back into sort of what the topics that we're going to talk about today with electrical distribution systems. So if we look at the industry and some of the reports that we see, Forbes released a report around the top 25 technology trends that will define the next decade. And some of the ones that I've picked out here, the sort of top sort of 10 to 15, they're linked back to things like artificial intelligence, Internet of Things, smart places, intelligent spaces, cloud, resilience, edge computing, digital platforms, facial recognition, voice interfaces, analytics, machine learning. And one of the ones that really sort of stands out and links back into, again, the electrical distribution and architecture is how intelligent spaces and smart places are evolving. It's closely linked to IoT And this is a trend in seeing physical spaces like homes, offices, and even cities becoming increasingly connected and smart. We look at the sector. So the smart sector is projected to generate around 9 trillion by 2025 from a McKinsey digital report. So the sector is significantly growing, and there's a massive opportunity that is coming with this evolution. What we can see is that the rate of adoption of new technology is also increasing at a phenomenal rate. So when we look at, for example, the fourth industrial revolution, which was a term coined by the World Economic Forum, which is about industrial revolution of cyber physical systems and the merging capabilities of both human and machine. It's an exponential change to the way we live and work. The speed and scope of this is unprecedented compared to previous industrial revolutions. So if we have a look at the example here of technology adoption in US households, so the landline telephone took nearly 100 years to reach 95% adoption. We start to compare that, for example, to the smartphone, and it took a mere 5 years to get to nearly 90% adoption. And what's really happening is that people, human beings, are really adopting this technology shift a lot quicker than ever before. And it's expected that this is going to become disruptive, and it's going to impact all disciplines, industries, and economies. So this technology disruption really has the potential to improve quality of life and work, and our environments then can become smarter and more connected. And with these evolutions, customer needs are changing, and the needs and wants are changing, and it's requiring new installer skills and knowledge to really satisfy this increased technology demand from end users and consumers. So we've got an opportunity to co-create the future as the new energy world becomes more electric. So 2 times faster growth of electricity demands compared to the energy demand by 2040. More digitized, so times 10 more connected devices expected from people by 2025. More decarbonized, so 82% of untapped energy efficiency potential in buildings and more than 50% in industry. More decentralized, so 70% new capacity additions will be renewable forms by 2040 as an expectation. So we've got this massive untapped energy potential, or energy efficiency potential. We've got approximately 58% in industry. We've got 79% in infrastructure, and we've got 82% unrealized potential sitting around the building space. So that sort of leads us on to the topic of smart buildings and the emergence of smart buildings, which is about to fundamentally reshape the way modern buildings and spaces are designed, built, and operated. It links into what we were talking about at the start around IoT, big data, software, and it starts to highlight opportunities for contractors and electricians where we can leverage cutting edge technologies such as IoT, big data, and intelligent software in really enhancing the experience of the occupants in that space and making it more attractive and desirable as a place to live and work. So it's about making the buildings smarter so that we can sustain optimal levels of performance and really make them highly energy efficient spaces, because the spaces can be personalized to individual preferences. And this is all around having real-time data being captured on the performance of the building and its space. And one of the key things really is that as more and more of these IoT and connected products are being developed, what's actually happening is that they're becoming a lot easier for the end user to use them, but also that the integration and the way that they're installed is starting to become far easier. So what are these sort of technologies that we talk about in these smart buildings or smart spaces? So the types of technology we're talking about is Internet of Things, IoT, so loads of sensors that are in the building that really connect all of the devices and are embedded in that fabric of the building to exchange information over networks. We then start to get predictive analytics that start to use data from these IoT devices, and we underpin that with intelligent software that can start to forecast how the building and its different systems are performing through its life cycle. Then we start to talk about topics of open standards architecture, so that the connected devices are talking the same sort of language and enables them to interact and exchange information. And then next generation power, so building fixtures, fittings such as lighting, information screens and security cameras, they're all on a network over Ethernet, allowing it to monitor its performance. And then we start to underpin with smart lighting and intelligent building management systems, so that they function like the brain of the building itself and connect all systems and devices together, so that you can start to take informed decisions to really improve the building's operation and functionality. So I'm going to hand over at this stage to James to start to talk about how the power distribution has started to change.
Thanks, Deepak. Yeah, so what I'm going to do is sort of look at how things have changed, and to do that, I'm going to take everybody right back to a traditional view of the power distribution model. It's slightly different these days to how it used to be, in that the used to be just a single source of power generation. It was very much a kind of a linear kind of production between the grid and the end user. So there wasn't any of what we've got now with feeding things backwards and forwards in and out of the grid. It's very one way. And the real main concern that was around power distribution was actually continuity of supply. So if we take a standard sort of average looking factory as a bit of an example, you can see that it's a fairly standard arrangement. You've got a main distribution room, so an area where it feeds the power into sort of the warehouse, the main processing plant, up to the different floors where you may have your meeting rooms or maybe a cafe or something. And some sort of lifts and things like that. It's very standard sort of looking. And if we put the electrical backbone onto this, what we can see is we have a main sort of switch room, as I've mentioned. This would be the sort of where you may have a kind of package substation of some sort. This would then go out feeding the main warehousing and that, and fed then up into the sort of the final distribution, up and down through the main building, the main floor itself. And as I said, the real only requirement for this would be the continuity of supply. The facility management team would work out of one main area, feeding and looking after the whole building itself, and they would work very kind of reactively. There wouldn't be any sort of information coming back to them as such from where they were. If they wanted to look at how much power was being used, they'd have to actually physically go out and take readings, and it would be down to problems being reported to them by other people, them stumbling on problems where maybe it might be a bit too late for them to actually make any difference. Apologies here, we're having a couple of technical problems. So one of the things that would be looked at to improve or continue and make sure the continuity of supply was there would be sort of at the design stages. The first kind of thing would be the selectivity process. So we'd always look at a main switch room with where your ACBs would be. That would then be kind of fed down to, say, a panel board with your molded case breakers. Then from that point downwards, you'd have into your distribution boards with your miniature breakers. So you'd always have that step down there. So you'd effectively allow the problem to be focused on one part of the building, rather than causing a sort of a bit of a cascade back to the problem to an area higher up the chain. The other area that would be looked at just try and move the slide on again, please. Sorry, the other area that we'd look at would be the cascading side of things. So again, this would be used alongside the selectivity studies that would be carried out. But what this would do is reinforce the braking capacity of the downstream devices. So what this would allow you to do is put in a smaller breaker further downstream, which effectively would then become a very much of a cost-saving exercise, as well as allowing the continuity of the supply of the building. If we look at now a more modern view of the distribution, you can see that yes, still continuity of supply is there. So we've got the traditional model, but we've also got a lot more information that we want to get out of the building itself, as well as information coming from the buildings. We want to feed power back into the grid itself. So there's a second form of generation in things such as wind turbines, maybe solar panels on the roof of the building, and all this wants to be measured to improve the energy efficiency of this building and any other buildings that may be owned by that company. So a very, very different model nowadays. The same electrical background is still there. Obviously, it wouldn't be possible to run a building without the electrical background. But over the top of that, we've now got a network of connectivity. So again, what this allows us to do is look at the different distribution areas in a bit more detail. The facility team would not necessarily have to then go out and gain the information from each device itself by physically writing the information down. What this would allow them to do is have a centralized point to feed the information back through the network, and not only look at the power, etc., that is being used, but also where there may be faults that could occur. So they'd be looking at it from a very much more proactive point of view. So feedback from things such as the status of the devices themselves could lead the facility team to look at problems that may occur before they actually occur. This would be done at different levels and with different amounts of sophistication. So if we kind of look first of all at the final distribution area, you'd have your pre-alarms, your load balancing, and your load indication, failure indication. So this would be the from a distribution point of view. Moving higher up, you could have more information again from a pre-alarm, but also your remote operation as well. So from this point of view, you could actually start operating the devices. For example, if one of the rooms or one of the areas on the estate had been the power left on, this could be flagged up to the facility team, and they could turn the power off remotely to start saving money and making a building more efficient. From a top level point of view, where the actual main LV power is, we're looking at crisis recovery, ways and means of getting information about that switchboard back up and running if there was to be a failure at that point there. So again, you've got the pre-alarms and things like that, but also sort of ways of optimizing all the assets from one single point. Using all these things that we've just looked at there, these can now be connected, collected, analysed and acted upon, depending on what information is being fed back. From this point here, with all this information gathered, we've got the real-time monitoring and the full control as mentioned, but also what this allows us to do is improve the performance of the actual site itself, giving you more efficiency within the building itself, and also then hitting sustainability targets that may have been set for each individual building. At Schneider Electric, we've looked at this from a three-layered architecture. So the first layer would be the connected products, which we'll kind of look at in a bit more detail. So the protection, the control, the metering, and then all of that connected together. We then move up into a more local form of information being fed back into what the layer we call edge control. And then finally, a more in-depth area, a more in-depth layer as we move up into remote analytics and services is kind of the top area. And all that in total is what we are calling our EcoStruxure power message and products. If we start looking at these in a little bit more detail, as we've seen, the connected products are there, allows us to connect everything together from a switchboard all the way down into the distribution, the final distribution area. Gives us the ability to sense information, look at all the information, but also while being very conscious of the cyber security aspect of it. So let's start putting some product into this architecture so we can see how we can do this with our products. At a top level switchboard, in the switch room, we would be looking at our Ocon boards, which would sort of contain our MTZ circuit breakers. These are very well connected already. You've got mobile devices that can interact with the product itself. This could then feed down into the NSX devices and onto the panel boards. So at this level, we'll be looking at maybe the Prisma, inside which we would have the NSX devices connected out. We'd also have then a next level down from an electrical point of view down into our power pack range, where we may have again the NSX, but also the NSXM, so the smaller, more compact version of the molded case breaker. And finally, we'd be looking at the final distribution at an Isobar level using the Acti9 devices. And this is all well and good when we look at a completely new building. This can be all implemented in one whole stage, one whole swoop. But using the products that are out there that we're able to look at building this around pre-existing and retrofitting buildings with this. So devices such as our power tag can be added onto pre-existing NSX breakers, or for that matter, the miniature circuit breakers down at that level as well. So it gives us the ability to monitor and look at and even control our devices at a different level once they've already been installed. If we then start looking at the next layer of our architecture, our edge control, we're actually looking at the information that's being pulled out of these connected devices. So at this point, we'll be looking at things such as our EcoStruxure Facility Expert, which is an app. So I've already mentioned there's apps available for the MTZ devices, but there's also an app that allows you to combine all of this information into one. So you've got all the building information in the palm of your hand. We've got the next level up where you've got the power monitoring expert, and then for the final layer we've got the SCADA operation. So that allows us to not only look at where devices are being used, but also actually allows us to operate them as well. Finally, we kind of look at the top level, so our remote analytics and services side of things. So this is taking all the information you're gathering, taking it away from the site itself. So it's a lot more remote, but it also allows us to get more information out of it. So things such as our power advisor, our resource advisor, and our facility advisor gives us a lot more information on the site itself from a more centralized point. So for example, if we'd got a building, a company, sorry, with multiple buildings around the country, we could use some of this software to gather information back to a central point, analyze it, and then move on and work on how we can help improve the efficiency of the buildings as a whole. So taking those into one whole area, one whole combined digital and electrical backbone of a building, we've got the 3 layers, all secure, but enabled. It's all open protocol, so it enables us to connect into other systems. It's fully scalable and flexible with current buildings, so it can be all retrofitted. But we're also future ready, so we're ready for things that are coming in the future. All this whilst maintaining a very required cybersecurity aspect of it. Now, I could carry on telling you about this structure and backbone that we've got in place, but I think what's probably best is that you hear from one of our customers and what they have done at Nottingham University.
The University of Nottingham is one of the UK's biggest universities. We have around 35,000 students and we're consistently ranked in the top 25 universities in the country. We want our campuses to be accessible to all. We want them to be healthy spaces and places where people can really be at their very best and achieve their very best. We've got some of the newest cutting-edge buildings that we're putting up now, but we've also got a lot of heritage buildings, listed buildings, where the ability to control and change and maintain constant internal environments is a real challenge for us. I'm Andy Nolan, Development and Sustainability Director at the University of Nottingham. I'm responsible for all of the new build and major refurbishment and the university's sustainability strategy, including all of its utilities management and building management systems. The big challenges for the university are to do things in a cost-effective and efficient way to reduce energy costs. And we see the BMS being a really important tool in helping us to achieve those objectives. We've evolved over the last few years from continuum into ecostructure. That's enabled us to really take it as an evolution rather than a revolution. It's enabled us to do things in a measured way, and it's also ensured that we've had business continuity and compatibility across the whole estate. And I think all of that combined has enabled us to drive through huge efficiencies, but also give us insight into how our buildings are performing and where we can make efficiency gains in kit, in plant, and in how we optimise the building's running conditions. We believe we're seeing somewhere in the area of around 5% reduction in energy consumption and around about 3% on overall energy costs. We've had a long partnership with Schneider, and that kind of close working relationship has enabled us to be at the front end of technology as it's developed and rolled out. The system and the investment will have effectively paid for itself in under 10 years.
So really what we're starting to see is that the infrastructure and systems start to become smart, and we're talking smart power systems and connectivity now. Connective technologies really can start to do the dangerous work for you. And the key pillars that we're really trying to underpin our platforms with are ensuring that we offer increased levels of resilience, increased levels of efficiency, and underpin that with sustainability. And as we develop and bring new products to market, we're really trying to ensure that they're future-proof for these evolutions of technology that are coming through. And with that comes the topics around ease of installation, speed of installation, increased safety. So ultimately, we're trying to distribute this electrical energy in a safe way, and the people that are in these environments are protected, and the people that install them have increased levels of safety. When you bring it together, we're trying to offer increased levels of visibility, and some of that is linked through connectivity and what you can see, where you can see it across the full electrical distribution system or smart power system. And then we underpin it with a simplified software backbone, which for Schneider Electric is EcoStruxure. So the systems start to become IoT ready. Ultimately, what we're trying to achieve is to enhance the levels of safety. So what really can start to happen is that you can discover potentially dangerous faults before they happen. You can start to perform and support maintenance cycles in a better way. Repairs and maintenance start to really become proactive rather than reactive, which has a cost implication in terms of how you then manage these repairs and maintenance operations. And essentially a connected solution is becoming essential. So the future is already here. This is not something to look forward to in 5, 10, 15 years. The connected landscape has already changed, and it's changing significantly in the electrical systems. And connectivity is changing the customer needs and technologies and what the demands are from the end user and the customers themselves. And connectivity really raises the bar for the services that we and yourselves can offer to our customers to really start to provide some significant added value. So ultimately, what we're trying to really bring is sustainability, efficiency, and resilience. And all of this combined with connectivity underpinning it as a consolidated system is where we can really start to see it coming into its own space. We'll pause at this point and we'll move over to a Q&A session. And if you just give us 1 second and we'll start that section off. Thank you. Thank you. So one of the frequently asked questions we find with this topic is when we start to have connected systems or multiple connected systems, what does it mean in terms of how they connect together? And what we're starting to see is across the Schneider Electric platforms, we've got a software backbone by the name of EcoStruxure. And what that allows us to do is to put multiple products, whether it's master packed MTZ, whether it's the power pack panel board, or whether it's Acti9 Isobar P with power tag, they start to sit on a common software backbone. And this is where it starts to bring quite a complex solution in a simplified format. I mean, there are even parts of the system, for example, with Acti9 Isobar P and Power Tag, that you can merely put onto an internet network or an Ethernet connection, and just at the base layer, you can start to get a web page that starts to give you a first level of insight, whether it's that your circuits are powered, active, whether you want to understand current, voltage, power factor, or even load balancing. So one of the topics that we sort of find with this is many people expect that the systems are becoming more and more complex, but in reality, as we're developing these systems, we're actually simplifying the way that they integrate together.
One of the other questions that we're kind of asked about with relation to that is whether technology is reliant on things such as ISPs advancing their systems as well. Well, in most cases, when we're looking at a local area, the ISP wouldn't have any kind of relevance to that whatsoever, because it would be done at a local level, and all the technology can be connected together within the local network. It's only when we sort of start moving up into the top level of the analytics side of things does then the ISP become relevant. So then, of course, the speed of the ISP would be relevant, but our software that is currently being used is more than capable of being used within all platforms that ISPs offer at the moment. So I think if we've got no further questions on those, I think we should draw this to a bit of a close there. One other thing that we do get often asked is about if there's any other training specifically on sort of the EcoStruxure itself. And yes, we can go into more detail, actually have people come out to you and speak to you in person, more one-to-one. Obviously, restrictions reliant on EcoStruxure itself. So I think if any more information is required, please ask the questions. Otherwise, if there's no others, we'll move to a close.
Thank you, James. So I think at that point there isn't any further questions. We wish you all a pleasant afternoon, and thank you for attending.
Yes, thanks very much for your time. Good afternoon.